Hello, my name is Matthew Binstead. I'm a scientist at the Pacific Northwest National Laboratories Joint Global Change Research Institute. This video will provide an overview of the GCAM-USA model, focusing on GCAM version 5.4, which was released in July 2021. Some familiarity with the Global Change Analysis model, also known as GCAM, is helpful for understanding the contents of this video. Please check out our other videos for an overview of the GCAM modeling framework if you're not already familiar with GCAM. GCAM-USA is a version of the Global Change Analysis model with subnational detail in the United States of America. GCAM-USA includes explicit representation of the 50 US states plus the District of Columbia and can be used to simulate energy, water, agriculture, and land outcomes in the United States under a variety of future scenarios. GCAM-USA is embedded within the global GCAM model, meaning that GCAM-USA simulates international and subnational USA outcomes simultaneously. Thus, outcomes in the United States are consistent with dynamically evolving international market conditions. GCAM-USA is included as part of regular GCAM model releases and is available for download on GitHub. Model documentation specific to GCAM-USA is available at the web address listed on this slide. GCAM-USA represents activities across several geographic units. Within the energy system, most but not all activities are represented at the state level. All energy services and final energy demands, including residential and commercial building services, industry, and passenger and freight transportation, are modeled at the state level. Fossil resources and extraction are represented at the national level, while solar, wind, geothermal, and carbon storage potentials are modeled at the state level. Most energy transformation processes, including electricity generation, refining, and biomass supply sectors, are represented at the state level, while gas processing and hydrogen production are modeled at a national scale. While electricity generation and consumption are represented at the state level, electricity supplies and demands are balanced at the grid region level. GCAM-USA's grid regions roughly align with the North American Electric Reliability Corporation, or NERC, assessment areas. Because electricity supply and demand are balanced at the grid region level, electricity prices are differentiated by grid region. Fossil fuel prices are also differentiated at the grid region level with cost adjusters derived from historical data that are held constant into the future. End-use sectors in all states face the same prices for hydrogen and biomass. The representation of land allocation and agricultural production is the same in GCAM-USA as in the core GCAM model. That is, land allocation and agricultural production are represented at the Hydrologic Unit Code 2, or HUC2, river basin level. Demand for food and other agricultural products, excluding bioenergy, is driven by national population and GDP, which will be discussed in more detail in the coming slides. Water operates at multiple scales in GCAM-USA. All water demands are tracked at the state level. The activities that drive water withdrawals are represented at the state level for some sectors, including municipal water, manufacturing, and electricity generation. For other sectors, the activity drivers for water withdrawals are represented at the basin level or national level. In these cases, demands are downscaled to the state level within GCAM-USA using fixed historical shares. Water supplies are modeled at the river basin level, with supplies and demands also balanced at the basin level. For states spanning more than one basin, water demands are allocated across basins using fixed historical shares. This concludes our broad overview of GCAM-USA. The following slides will provide a bit more detail on some key sectors. Future changes in population and labor productivity, or gross domestic product, are specified exogenously in GCAM and set the scale for activity in the energy and land systems. GCAM-USA includes state-specific population and labor productivity growth pathways. National population and GDP are updated to match the sum of states assumptions. State-level population and economic growth assumptions are based on historical values through 2018. Future population growth is based on downscaled assumptions from Shared Socioeconomic Pathway 2. Future economic growth assumptions utilize census region per capita GDP growth rates from the U.S. Energy Information Administration's Annual Energy Outlook 2019, and then converge to the common SSP2 labor productivity growth rates in 2100. Overall, the GCAM-USA reference scenario entails a growing U.S. economy and growing but gradually peaking population through the end of the century, which drives corresponding growth in energy service demands across all end-use sectors. GCAM-USA has increased detail in the electricity sector compared to the core GCAM model. Electricity supply in GCAM-USA is divided into 4 representative load segments: baseload electricity, intermediate electricity, sub-peak electricity, and peak electricity, based on an annual load duration curve. This structure better reflects the intra-annual variation of electricity demand. Technologies compete in different load segments based on how they are expected to operate. For example, nuclear technologies are available in the baseload segment, while gas turbine technologies are available only in the sub-peak and peak segments. Other updates to the GCAM-USA electricity sector focus on making the future fuel mix more consistent with current laws and expectations. For example, new coal power plants without carbon capture and storage, or CCS, are not allowed in the GCAM-USA reference scenario, consistent with Clean Air Act Section 111B New Source Performance Standards. GCAM-USA also includes state-specific retirement pathways for existing coal and nuclear power plants based on announced retirements and the age structure of those plants in each state. Finally, as mentioned earlier in the presentation, electricity generation and consumption are represented at the state level, but electricity is traded within 15 grid regions which roughly align with the North American Electric Reliability Corporation assessment areas. Of these grid regions, 6 represent single states: California, Texas, Florida, New York, Alaska, and Hawaii, while 9 represent clusters of states. Electricity trade between grid regions is limited and assumed unlikely to expand significantly in the future. GCAM-USA also features increased detail in some end-use sectors. The GCAM-USA building sector represents 14 residential energy services and 10 commercial building energy services, compared to 3 each in the core GCAM model. In addition to space heating and cooling, both the residential and commercial building sectors include services such as lighting, water heating, cooking, and various appliances. Each of these services can be provided by multiple technologies, including low and high efficiency options that are powered by a variety of fuels. For example, residential heating can be provided by oil, gas, biomass, and electricity, including both electric furnaces and electric heat pumps. GCAM-USA's industrial sector has the same level of service and technological detail as core GCAM, but includes a vintage structure which reflects the long-lived nature of industrial capital. Currently, GCAM-USA contains a partial picture of greenhouse gas and traditional air pollutant emissions. Carbon dioxide emissions are driven by activity in the energy and land systems at the state, basin, and national level. However, non-CO2 emissions are not included for any activities represented at the state level in GCAM-USA. For this reason, GCAM's climate model, Hector, is disabled for GCAM-USA scenarios. Including a complete accounting of emissions in GCAM-USA is an active area of model development. This concludes our overview of GCAM-USA. The model code, input data, and documentation are available at the links below. Thank you for your attention.